Good afternoon, everybody. I want to welcome you to the Southeast Climate Adaptation Science Center seminar series. That is a mouthful. Our goal at these virtual gatherings is to provide a platform to highlight and discuss research that supports resource management across the Southeast. My name is Michelle Jewell, and I'm the Communications and Engagement Manager for the Southeast CASC. Okay, normally now I would be introducing all of our speakers together, but for the case or for saving time for our speakers, I'm actually going to turn it directly over to our speakers to introduce themselves at the beginning of their talks. The order of our talks today are going to be 3 of the many newly funded projects. There will be another round of lightning talks coming up in the spring with other projects too. But today we're featuring these projects, and they are: number 1, Ghuts, Grit, and Gills, synthesis of hydraulic, water quality, and ecosystem data for climate adaptation planning. Number 2 is improving land change models for climate adaptation, urban development, and conservation action across the U.S. Caribbean. And number 3 is urban tree health in socially vulnerable neighborhoods in the Southeast and ecological and economic assessment. With that, I will stop sharing and I will turn it over to the team Ghuts.
I guess that's us, right?
That's us, yeah.
So I'm Torsten Nappenberger with Auburn University.
I'm Eve Brantley. I'm the Associate Director of Extension at Auburn University.
And I'm Leanne Bear. I'm a student intern here.
And I'm David Hensley at the University of the Virgin Islands. Good morning, everybody.
All right. Well, I'm going to kick off with our introductory slide, and you see our partners at the bottom: University of Virgin Islands, Auburn University, Oklahoma University, and of course USGS and the Climate Adaptation Science Center. We greatly appreciate the opportunity to work on this project through your funding. The very catchy title, Ghuts, Grit, and Gills, relates back to some of the unique challenges that the Virgin Islands have. Well, maybe not unique, but as it relates to being an island system, Ghuts, and David can talk in depth about this, Ghuts are the rivers and the streams that flow through the Virgin Islands landscape. Grit is associated with the sediment impacts that we see from some of the excessive rainfall and, of course, extreme conditions that we know are occurring with climate change and weather. And then Gills for the impacts not only in those freshwater systems, but in those near estuarine areas and habitats that result from impacts of upstream. So we will share with you today our project, the synthesis of hydrologic, water quality, and ecosystem data for climate adaptation and planning. So I'll turn it over now to my colleague, Dr. Nappenberger.
Thank you, Eve. And I will provide a little bit of background. So water promises to be one of the most important avenues through which climate change affects the Virgin Islands. And for better climate change adaptation, we need to use scientific approaches based on data looking upstream. But water data has been difficult to obtain for the Virgin Islands, cutting across many disciplines: water quantity, those are the Ghuts, water quality, grids, and then freshwater ecosystems, the Gills. And now David will talk about our project goals.
Yes, so the goals of this project with those challenges in mind is that in the Virgin Islands, especially when it comes to finding this water data, like other places, but especially here because of our size, there are a lot of actors that exist and from different agencies, different disciplines and motivations. And that's part of the reason why to date, there's been no effort to centralize this data for the Virgin Islands specifically to make it more accessible in a small community. And so the result of that is that now this project is that we do want to try and do that, begin the process at the very least, to collect it together into a permanent repository, that which we can, but also the goal here is to synthesize and learn some lessons from the process about what did we find it difficult to find, what do we think maybe doesn't exist, and identify these priorities and gaps. So another major goal of the project at the end is a white paper that summarizes that. And the kind of core activity that this project is all about is coming together to do this water data workshop next year, where leading up to it, we'll be collecting the data and bringing people together to identify those priorities together. So, you know, there is data out there. It's always important to acknowledge that, even if we are limited. A lot of it comes from many of these federal and local agencies that we know. But the big issue is that there's a lot that we know we don't know, because I can speak for myself. I'm always discovering new kind of unheard of, somewhat obscure sources that nobody in the community locally is aware of. And so that's kind of what this project seeks to begin to redress. I wouldn't claim we're going to find everything in this project, but so to take you through, this is kind of a discovery process, I suppose, but to take you through the kind of steps that we hope to follow through with the data gathering phase. This is one of the major prongs of the project. Of course, there are physical records that don't exist in digital form. We're trying to collect as many of those as we can. We are going to have to, because of the size of our community, do some personal canvassing and reach out through our networks and see what we can find. It's frequent that we hear about data and then that's the end of it. But now we want to actually collect it and bring it together so that it's not lost over time. So that does include some scanning and digitization. Again, not probably everything, but hopefully the bulk of it, or at least beginning to get the inventory of what is out there. And with that process and for other digital data that we find, we would do some limited QA/QC, again, as much as time allows, but enough to get it into this repository. And the focus on that QA/QC is much more about intelligibility for future generations, right? So that people who come after us don't have these difficulties and also that we're able to begin filling these gaps in a more kind of rational way. So that the focus is really the permanence and the future here, so that we can adapt to climate change the way that we will need to do. So that's our workflow that you're seeing there. But the real focus, I mean, we're beginning that data collection already, but the real focus is this synthesis workshop. Kind of serves several functions at once. One is to use it as a catalyst to get actors to actually bring together that data and, you know, hand it over, basically. A little impetus there. We have already held a stakeholder meeting of kind of some of the key players who would be most interested in this meeting and have already come together in a meeting to help plan it and get it kicked off. But this is also, even if we haven't discovered data by the time of the workshop, it's a major opportunity to solicit even more data and discover, you know, gaps that remain. And another huge thing from the human point of view is it's going to bring us onto the same page. Everybody in that room will kind of walk out of there with an understanding of where we are, right? Which is something that currently I'd say most of us don't quite have, at least not the same picture. So this way, we all work together, a lot of these stakeholders in the Virgin Islands, and we'll be able to have this common reference point in the future. And that will allow us to have this synthesis paper as well, a kind of a reference document that we'll be able to refer to in the future or give to people who weren't there or for future generations to see, for us to kind of plan our adaptation work into the future. So that is the gist of it, the data collection and the synthesis workshop. So I just want to thank everybody for listening.
Awesome. Thank you so much, Team Ghuts.
Thank you all for
Thank you.
being part of our presentation.
Thanks, everybody. So I'll turn it over to Georgina and Manuel to talk about. Oh, sorry. Did I get you, Georgina?
Yes.
Okay, great. I'm turning it over to the both of you. Sorry, I had some feedback there about improving land change models for climate adaptation, urban development, and conservation action across the U.S. Caribbean.
All right. First of all, can you all see my screen? Yes. All right. I have some thumbs up. I am thrilled to be here, especially sharing the stage with Dr. Manuel Valdez-Piscini. For those of you that don't know me, my name is Georgina Sanchez. I'm a research scholar and faculty fellow with the Center for Geospatial Analytics at North Carolina State University, and I am the PI for our project. Manuel, can you introduce yourself?
Sure. My name is Manuel Valdez-Piscini, and I am an anthropologist, a researcher at the Center for interdisciplinary coastal research here at the University of Puerto Rico in Maya West, and one of my areas is human coastal processes.
Wonderful. More and more we see how these headlines about communities impacted by sea level rise, recurring flooding, how they're being often displaced, becoming climate migrants. But at the same time, we see areas that are quote unquote those nice weather that have environmental amenities are becoming pull factors that are attracting growth. And of course, this trend is no different in the US Caribbean, the rush for a slice of the paradise. Let's take a look at some high-level numbers. Here we have population estimates for the US Virgin Islands for 2000, goes from 2000 to today, and you can say that it changes color as we looked into some projections through the year 2050. We see a slow but steady decline, which projections suggest may become more pronounced. Overall, this represents a projected population decline of about 24% for that 2000 through 2050 period. Now, here we have the same population estimates and projection, but now for Puerto Rico. An even steeper population decline. For Puerto Rico, this represents a projected population decline of about 43% for that same period of time, 2000 through 2050. And now I'm going to zoom into this period of 2014 through 2020. Again, just for Puerto Rico, for this example. We see that population dynamics, then it becomes a little bit more, it provides us a little bit more of a detail when we see that change through time, not just that decline. And as we introduce another interesting and important factor, here we have a couple of different interesting dynamics. We have the boom in short-term rentals across the Caribbean, well, specifically across Puerto Rico in this case. Effectively, we see that the same trend of population decline is paired with a rise in the numbers of active Airbnb listings. And this is work made by Raúl Santiago Bartolomé and his colleagues, where they really evaluate how short-term rentals are responding not just to that seasonal tourism variation, but also to disasters. After Hurricane Maria, we see a clear decline in listings. But also after COVID-19, we see that the market was impacted. And what they find and what we have seen is that the density in short-term rentals, as it increases, then the price of long-term housing becomes impacted because it also increases. So this dynamic between short-term rentals and availability of the market and prices are also impacting the ability of local communities to make decisions, long-term decisions about where to stay and the resources that they might have for housing. And the combined effect, of course, of this population dynamics affects the combined effect of population dynamics with climate stressors, economic drivers. It results in changes in our landscape. So here we have a couple of maps, and I'm going to be showing a little bit of change through space and time. There are many interactions and many interesting aspects that we can see, but what I really want you to take a minute to look through as I move the time scale and we see variations through time, is that how the intersect between population dynamics, climate stress, and economic drivers are ultimately changing the landscape, the way in which we use the land, but at the same time, how this is driving potentially development near conservation areas, near those ecosystems that we care and value and that we may want to protect. So here we have the 1990, 2000. So you start to see some changes, an increase in pasture and rangeland, of course, an increase in developed land area throughout the different islands. You see the main one, of course, Puerto Rico and the U.S. Virgin Islands. Now we're 2010, 2020. Hopefully no one is blinking. But you see that change in population now, so that things make a little bit more sense. Let me put things in context. So now we have the full change through time. And overall, of course, we see a bit of a decline in forest and developed area that has, it's a result of a number of things, data quality and changes that have been just land use changes impacted that were a result of disasters. Of course, Hurricane Maria being one of them, one of the main ones. And of course, an increase in change in pasture, rangelands, and so on and so forth, which are the main dominant land use for the whole US Caribbean. I'll pass it a little now to Manuel. Manuel, would you like to talk to us a little bit more of how then our project brings in some of these components in terms of land change dynamics and how we're introducing these dynamics for the local realities of the region?
Sure, there is a lack of knowledge that we have at this point because of some fiscal issues with the government. There is a lack of funding for the Department of Natural Resources, and that being a major hit to the way we conserve the resources. So we are dependent now on several federal agencies and also in local NGOs who are basically protecting the areas. So there is also a lack of a formal territorial planning process that was stalled in the like seven years ago, because the private sector didn't want the plan to reserve some areas for conservation and agriculture and other activities. So therefore, it is an open field for the private sector to start developing. Over the last 10 years, the construction industry was downhill, but now is picking up, and it is also impacting some critical areas which are surrounded by protected, the coastal protected areas, and this project will definitely provide information for decision making and also to understand what will be the impact of those construction projects in the coastal areas of Puerto Rico and all over Puerto Rico, not only in the coastal areas, because it is happening in the El Yunque National Forest, in the surrounding areas of El Yunque National Forest to the east of the island, and many other areas. So this project will provide plenty of information and for the decision making and to conserve those particular areas.
We are collaborating with a number of different partners in this project, among them NOAA, U.S. Fish and Wildlife Services, of course, the Southeast Conservation Adaptation Strategy being part of the U.S. Fish and Wildlife Services, and the Forest Service. If anyone would like to know more about the project or enter our partnership, feel free to reach out. But if not, we will wrap up here, and we're happy to take questions if anyone has any.
Thanks, Georgina. Thanks, Manuel. Next, I'll turn it over to Meredith Martin, our third and final talk of this lightning talk series, about their project on urban tree health in socially vulnerable neighborhoods in the Southeast and ecological and economic assessment.
Great, thank you, Michelle. Yeah, so this is a mouthful of a title, because I'm presenting on behalf of our team based here at NC State University. And we are focused on looking at urban tree canopy composition and health across multi-scale, so across the region of the Southeast, and then also zeroing in on Durham. And this is going to be a really fun interdisciplinary project, looking at sort of forest ecology from an urban forestry perspective, looking at ecosystem services, and also looking at economic cost benefits analysis. So just as a very quick introduction, urban forests have become increasingly important for the ecosystem services that they provide. This is a map showing land use change, just like we saw in Puerto Rico, maybe a little more dramatic here. This is from 1940 to what's projected for 2030 in the state of North Carolina. And you can see dramatic increases in the amount of housing units and in the density of housing. These are showing the areas of lots. And so we have a lot more of these really small lots and just a huge amount of urbanization going on in North Carolina, but also across the southeastern US. Some of these are the fastest growing cities in the country. Urban forests provide a lot of benefits, economic benefits in terms of property values, in terms of providing shade and lowering cooling costs, things like this, a lot of environmental benefits, air pollution, water quality, wildlife habitat, and also social well-being, health benefits to people who have access to green spaces. But we have a real lack of focus on urban forestry research within the Southeast. There have been a few studies looking at urban tree mortality. The only ones that I could find were in Florida and Puerto Rico, so that's skipping most of the Southeast region. And we have no studies that are yet looking at the potential impacts of climate change on urban tree species composition and urban tree canopies. And as you can see in this image, these are the number of days per year with peak temperature over 90. So it's one way of looking at future climate change. And we can see from the 1960s, 70s, moving to about 50 years from now, 2080, we're going to see dramatic increases in temperatures across the region, or at least in maximum temperatures. So our project is hoping to fill some of these gaps by looking both at a smaller scale analysis focused on the city of Durham in North Carolina, where we're hoping to do a more detailed assessment of the urban canopy, model some ecosystem services provided by that canopy, and use cost benefits optimization models to look at the economic and ecological benefits of tree planting and maintenance. And then the second part of our project is really to broaden out to do a synthesis of regional urban canopy inventory data. So both looking at sort of meta level of what type of data is out there, and then also looking at really what are differences and patterns that we see within the urban canopies across the Southeast. And then ultimately, we're hoping to use this to look at some future sort of scenarios with climate analogs. So I'm going to go into a little bit of detail on these. These are the lead PIs. So there's myself. I'm the forest ecologist on the team leading the project. Dr. Justin Baker is an economist who's done a lot of work on cost benefits modeling. And so if you have any questions about that, I'm not the best person to answer, but I'm happy to pass you on. And then Dr. Jen Richmond Bryant is really bringing a sort of ecosystem services, air quality modeling, and environmental justice perspective to the team as well. We're lucky to have some great community partners. We've had to make a few shifts in the start of our project with community organizations moving around, but our main two partners are Keep Durham Beautiful, which is an organization based in Durham. Tanya Doutlik is the executive director, and they are focused on planting trees in the city, but also doing trash removal, beautification efforts, and really have an environmental justice component to their organization, which is fabulous. And then we're also going to be working closely with the city of Durham. The city of Durham, it turns out, also just got a large Inflation Reduction Act grant to do some work on their own tree canopy. They're planning to plant about 4,000 trees and redo some of their urban inventory. And this sort of happened as we've also been getting our award. So I think that this is a really nice opportunity to work together and make sure that we're maximizing our efforts and not overlapping, and make use of their ongoing work, improving their own city canopy as well. They do. Oh. There we go. Sorry. They do have some existing canopy data. It's not complete. They are going to be redoing their inventory. But one of the things that they're interested in, speaking with the urban forestry manager, is really looking at what are some of the factors that impact tree condition. So are there particular species that are really vulnerable? Are there particular planting methods? Keep Durham Beautiful is particularly interested in looking at planting methods and also sort of planting success when we have volunteers planting versus professionals hired by the city. So that's one of the things that we are going to be working on with our analysis. I also, I think I actually saw Renata in the audience here. There's a recent dissertation from this year focused on a comparison of urban tree health in Durham and also in Chicago. And so we're going to be hoping to make sure that we can integrate this analysis into our work as well. And again, not repeat efforts that's already been done. For our ecosystem service assessment, we're going to be using Purple Air data. Purple Air has these low-cost air monitors, which have sensors for particulate matter, as well as surface temperature, relative humidity. There's monitors throughout the nation, and there are 11 active monitors in Durham right now reporting to the Purple Air Network. So we're going to be using these as part of our analyses in terms of assessing relationships between urban canopy, directly between urban canopy and air quality as one of a key ecosystem service. And then we're going to be building on work from a PhD student here, looking at cost benefits, economic cost benefits analysis of tree planting. This was an analysis that was done on a rural level, looking at tree planting under different policy incentive structures. And we're going to be trying to change this model to really apply it to urban settings with Durham as a case study. But this will then be a model that could be used more broadly in other urban environments, looking at optimizing the potential incentives for tree planting in urban settings. And then the last section is this regional analysis. So back in 2020, there was an analysis that was done in the Northeast, looking at a survey of tree planting programs and kind of analyzing what species are dominant, whether it's fitting into sort of the 10, 20, 30 rule in terms of not planting too many of the same tree. And so we're going to be applying this within the Southeast, but taking it a few steps further. So we've already worked to identify 166 cities across CCASC states with populations over 50,000. And we are starting to pull in information. I've got a fabulous PhD student working on this now, pulling in for information about what they have available in terms of canopy inventories, grants, who is planting their trees, things like that. And a lot of different cities have this information publicly available. These are some examples from larger cities, Trees Atlanta, Charleston, South Carolina. They have these different tree maps. And so we're going to be working to really pull information from these public databases and then also reaching out directly to municipalities. And part of our analysis here is both to have a synthesis in terms of what urban inventory information exists. Is that available data sort of equitably distributed, looking at different social vulnerability indexes across cities and across states, and highlighting areas where we really could use more data in order to manage our urban forests better. And then the other part of the analysis will be really looking at the actual urban canopies themselves. So are there patterns that we see in terms of tree species, tree genera, tree families that are being planted across the region? Are there correlations between those species compositions and climate factors? And ultimately, we're planning to use climate analogs to compare how do current canopy distributions in these urban settings compare to the canopies in their sort of future climate analog. So for example, by one estimate in 2080, Durham's climate will feel a lot closer to Tallahassee, Florida. And I'm guessing, we haven't done the analyses yet, but I'm guessing that our urban canopies are going to look pretty different. So we're hoping that this information can also help think about climate adaptation strategies in terms of planting sort of assisted migration of urban trees. So I don't have a thank you slide, but thank you very much for having me. I'm happy to answer any questions.
Thank you so very much. Thank you so much. It is a feat of nature that we were all able to align everybody's calendars on one day to be able to talk about your upcoming projects. So thank you very much for lending your time and your expertise and answering all the questions about the projects. Really love lightning talks because, as you can see, there's so many connections that can be built from just getting together and talking about all the work that's happening in the Southeast. Thank you for everybody for turning up, and we'll see you in the next few weeks.